Q23, we have primarily what we were given a graph, so we just need to pick out this information. So what are the roots of f? The roots are where it crosses the x-axis. So we're going to get one right here at, that's negative 5, 6, 7, 8, 9, 10. So that's going to be, there'll be one at negative 7. These will all be sort of x equals, right? When x is negative 7. We get another one here at 1. And then another one here at positive 6. So that's where it crosses the x-axis. The y-intercept, that's where it crosses the y-axis. That's going to be at y equals negative 1. And again, you can also write these as ordered pairs because those are actually points. So the x values would all have y being 0, and the y-intercept has x being 0. Identify the inflection points of the function of f. So that's going to be where we are going from concave up to concave down. So they're halfway between these maximum values. So it's going to be somewhere around here. And really the best is generally it's going to be about halfway between these 2 points here, but not always. Between this one, looks like, you know, where's the inflection point is going to be about there. We'll call that negative 1, negative 2. Identify the inflection points. So that's going to be x value of negative 2. And that looks like it will be about negative 8. And again, when we get to calculus, there's actually ways to calculate that. What I'm going to do while I'm here, I'm going to see, let's kind of look ahead what they're actually, the answer key has for us. So far we're good. Yeah, x equals 1 has a multiplicity of 2. I don't know if we talked about that. We talked about c, negative 1. So I guess all they're looking for the inflection points is what's the x value, right? C, identify the inflection points. Negative 1 and 2. Yeah, without the calculus, it's hard. Okay, I guess, yeah. Where does it really change? I could go with that. There's no question like this on there. And then at 2, I would, I'd rather put it about 3. So let's not worry about inflection points. It's not on the exam. And to really be able to do this, you need calculus. Approximate on the intervals of function is concave up. So concave up is certainly from here to here. So basically it's always concave up back this way. So we're concave up from negative infinity until we get to the inflection point, which they say is negative 1. And then we're going to be concave up over here again. So that would be, as they're saying, from 2 to infinity. I would call it more like 3. So I don't, but again, there's not a question on this. The end behavior, as x goes to infinity, what's happening? Here's x is going to infinity. What's happening to y? It is also going to infinity. The end behavior as x goes to negative infinity. That's this direction. And what's happening to y? It's also going to positive infinity. Is this function even or odd degree? Well, when they both go in the same direction, it has to be even. An odd degree goes something like that. or something like this. So they go in opposite directions for the end behavior. Approximate on the interval the function is increasing. Okay, so that's where is it going up? So it's basically increasing from this, so negative 5, from negative 5 until we get to this point here, which is 1. That interval that's increasing, decreasing here, increasing again from this point, which would be 4. We'll do a union from 4 to infinity. Okay. The places it's decreasing are the opposite, so it would be from negative infinity to negative 5. And then it increases, and then it's going to be decreasing from 1 to 4. Approximate on which intervals the function is positive. That's wherever the y values are above the x-axis.